Hello and welcome. I'm Jarvis. In this lesson, we're moving into intermediate territory to explore two powerful tools in your SQL arsenal, subqueries and the union operator. These techniques will allow you to solve more complex problems and structure your queries in a more logical, readable way. By the end of this 20-minute session, you will be able to confidently write subqueries in a where clause, understand the crucial difference between correlated and non-correlated subqueries, and combine result sets using both union and union all, knowing exactly when to use each. Let's start with subqueries. Simply put, a subquery, also known as an inner query, is a query nested inside another SQL statement like select, insert, update, or delete. Today, we'll focus on its most common use case within a where clause to filter data based on the results of another query. A subquery can return a single value, which we call a scalar subquery, or it can return a list of multiple values, a multi-valued subquery. When working with multi-valued subqueries, we typically use operators like in to check if a value exists in the list returned by the subquery. The most straightforward type is a non-correlated subquery. Think of it as an independent query. It runs once, gets its result, and passes that result to the outer query. The outer query then uses this hard-coded result to complete its own execution. There is no back and forth. Now, a correlated subquery is more complex. It's dependent on the outer query. For every single row processed by the outer query, the inner query runs again, using a value from that specific outer row. This can be powerful, but also performance-intensive, as the inner query may run hundreds or thousands of times. All right, let's move to a practical demonstration. We'll be working with two simple tables: authors, which has an author ID and author name, and books, which has book ID, title, and the corresponding author ID. Our goal is to find books written by authors whose names start with J. First, we write the inner query to get the author IDs we need. Select author ID from authors where author name like J%. This query returns a list of IDs. Now we wrap this in our outer query. Select title from books where author ID in, etc. The in operator is perfect here, as it checks if the book's author ID is present in the list returned by our subquery. Let's run this in Management Studio. Excellent. Now let's switch gears to our second topic, specifically union and union all. These operators are used to combine the result sets of two or more select statements into a single result set. This is incredibly useful when you have data of a similar type spread across different tables. Here's the critical difference. Union scans the combined results and removes any duplicate rows, giving you only unique entries. Union all simply appends the second result set to the first, duplicates and all. Because it doesn't have to do the extra work of checking for duplicates, union all is significantly faster. To successfully use union or union all, there are a few rules you must follow. First, every select statement within the union must have the same number of columns. Second, the columns must also be in the same order. And finally, the data types of the corresponding columns must be compatible. For our next demo, imagine we've just added a magazines table to our database. It has magazine ID and title. Our task is to create a single consolidated list of all publication titles from both our books and our new magazines table. The query is very straightforward. We write our first query, select title from books. Then we add the keyword union. And finally, we write our second query, select title from magazines. SQL Server will execute both, combine the results, and remove any titles that appear in both tables. Now, let's swap union for union all and observe how the output changes if there are duplicates. Let's talk about a very common pitfall.
Many developers default to using union without thinking. Remember, if you know for a fact that your result sets won't have duplicates, or if duplicates are perfectly fine for your report, always use union all. It avoids a costly sort operation and can make a huge difference in performance on large datasets.
So, where would you use this in the real world? You might use a subquery to find all employees who work in the same department as a specific person, like Jim. For union, a classic example is combining data from an active customers table and an archived customers table to create a comprehensive mailing list for a yearly report. All right, let's quickly recap what we've covered. We learned that subqueries are queries nested inside another statement, perfect for complex filtering. We contrasted non-correlated, run-once subqueries with correlated subqueries that run for each outer row. We then used union and union all to combine result sets, stressing the performance benefits of union all when duplicate removal isn't needed. Thank you for joining me today. You've just added some powerful intermediate skills to your SQL toolkit. I encourage you to practice the exercises. In our next lesson, we'll dive into the world of common table expressions, or CTEs, which can often be a more readable alternative to complex subqueries. I'll see you then.